In this video, we're going to talk about quadratic equations. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a is not equal to 0, and where a, b, and c are real numbers. A quadratic equation written in this form is said to be in standard form. Now the zeros of the quadratic function f of x equals ax squared plus bx plus c are the solutions of the associated quadratic equation ax squared plus bx plus c equals 0. Quadratic functions can have real number or imaginary number zeros, and quadratic equations can have real number or imaginary number solutions. So the first thing we're going to look at is the principle of zero products, which states that if a times b equals 0 is true, then a equals 0 or b equals 0. Similarly, if a equals 0 or b equals 0, then a times b has to equal 0. So what we're going to do is we're going to use the principle of zero products to solve these first two examples. So the first example says solve the following. You have 3x squared plus 9x equals 0. Now to solve this type of equation, what we want to do first is factor out our greatest common factor. So here I should see I can factor out a 3 from each term as well as an x, so I can factor out 3x. So 3x, so I need to go back to a normal pen, sorry about that, 3x parentheses x plus 3 is equal to 0. So 3x times x gives me 3x squared. 3x times 3 gives me the 9x. And now what the principle of zero product says is that if the product of 3x and x plus 3 equals 0, then what we have to do is set each of them equal to 0. So 3x equals 0 and x plus 3 equals 0, and solve to see which values we get. So for this first one, that just leaves me with x equals 0 and x equals negative 3. So I just subtracted 3 from both sides. Now note that we can check our answers by plugging them in to the original equation. So if I plug in 0, I get 3 times 0 squared, so 0, plus 9 times 0, so plus 0 equals 0. Works out. And I can do the same thing for the negative 3. Now, the second one is a little bit more complicated because I need to factor out this quadratic. And the coefficient in front of my x squared term is not 1. So what that means for me is I have two possibilities. I can use the guess and check method or the AC method that we talked about in intermediate algebra. So I'm going to use the AC method. Now recall that the AC method means is that I need two numbers that multiply to give me the product of a times c. So they're going to multiply to give me 3 times negative 6. So they're going to multiply to give me negative 18. But they're going to add up to give me whatever this b term is. So they're going to add up to give me c. So it may take a little while, but you should find that that would be 9 and a negative 2. So I'm going to rewrite this equation as 3x squared plus 9x minus 2x minus 6 equals 0. Now the whole idea of why I did this is so now I can factor by grouping. Now if you look, I didn't change the meaning of this original equation because the 9x minus 2x would give me the positive 7x, right? What it does is it allows me to factor by grouping so I can easily factor this out. Alright, so what can I factor out of these first two terms? Once again, I can factor out a 3x. So that gives me 3x parentheses x plus 3. Now I want to factor something out of these next two terms so that I'm left with x plus 3 in parentheses. So what I'm going to factor out is a negative 2. That gives me x plus 3 in parentheses. Now recall that when we do our factoring by grouping, these two values are going to group together. So I'm left with 3x minus 2 times x plus 3. So now that we have that original quadratic equation factored out, now I can use the principle of zero products to set each of these equal to 0. So I'm going to take this 3x minus 2, and I'm going to set that equal to 0. So that gives me 3x equals 2, because I add 2 to both sides. Divide both sides by 3, and that gives me x equals 2/3. So that's my first answer. And then I take x plus 3, set that one equal to 0, and that gives me x equals negative 3. So I have two solutions, which once again I can plug into my original equation to solve. Now the next thing we're going to look at is the principle of square roots. Now this is a concept that a lot of people tend to have a little bit of trouble with. So please make sure you're taking special notes here. What the principle of square roots states is that for any real number k, if x squared equals k, then x equals square root of k, or x equals negative square root of k. Very often people only look at the positive, they forget about the negative. So be very careful and mindful of that. Alright, so what that means for us. We've got an example of x squared plus 25 equals 0. So the first thing I'm going to do is I'm going to subtract that 25 from both sides so I isolate my variable. That gives me x squared equals negative 25. At this point, I'm going to use the principle of square roots, and I'm going to take the square root of both sides. When I do that, that gives me x equals plus or minus the square root of negative 25. Now I, of course, am not going to leave my answer in that format because we've already talked about complex numbers, so I know I can simplify that to x equals plus or minus the square root of 25 times the square root of negative 1. So x equals plus or minus 5, because the square root of 25 is 5. Square root of negative 1 is I. So I end up with two solutions. I end up with a solution of 5i and negative 5i in my solution set. Now for this next one, I'm going to go ahead and I'm going to add 16 to both sides. So that gives me x minus 7 in parentheses squared is equal to 16. So now I have my squared term being isolated. It's all by itself on one side of the equation. That's very important before I can use the principle of square roots. At this point, I can take the square root of both sides. And that gives me x minus 7 equals plus or minus the square root of 16. In other words, x minus 7 equals plus or minus 4, because the square root of 16 is 4. So now what I'm going to do is I'm going to add my 7 to both sides. So that gives me x equals 7 plus or minus 4. Now you don't want to leave it in that way. You want to give me a final answer. So what you're going to do is you can break this up into two separate equations to give me the two separate answers. So you can go ahead and write x equals 7 plus 4 and x equals 7 minus 4. Now when you do x equals 7 plus 4, that gives you x is equal to 11. When you do x equals 7 minus 4, that gives you x is equal to 3. Alright, so let's keep the fun going and talk about solving quadratic equations in x by completing the square. Alright, so let's first talk about the steps to solving a quadratic equation in x by completing the square. The first thing you want to do is isolate the terms with the variables on one side of the equation and arrange them in descending order. Then you will divide both sides by the coefficient of x squared if that coefficient is not 1. Then you'll complete the square by taking half of the coefficient of x and adding its square to both sides. Alright, now this portion ignore because it's a typo and it just reprinted it. So step 4 involves rewriting the trinomial as the square of a binomial. And this will make a lot more sense in just a second. I'll color code and try to make this as clear as possible for you. Then step 5 means you're going to use the principle of square roots. I have square roots. And then step 6 is solve. And step 7 would be to check your answer. You always want to check your answer. Alright, so let's look at this one step at a time. First thing you want to do is isolate the terms with variables on one side. So what that means is I'm going to take that 6 and I'm going to move it to the other side. So that's going to give me x squared plus 6x. Now, what I do at this point personally is I leave a placeholder. So what I do is I put plus blank equals 6 plus blank. And I'll show you in just a second what's going in those blanks. But it's to remind me that I'm going to add something to both sides of the equation. Now here, you don't have to divide anything as far as the coefficient of x squared because the coefficient of x squared for this particular problem is 1. Alright, so now what you're going to do is you're going to complete the square by taking half the coefficient of x and adding its square to both sides. Alright, so what that means for me is I'm going to take that term in front of my x, so that would be my 6, and I'm going to divide it by 2, And then I'm going to square it. When I do that, that gives me a positive 3 in parentheses squared, which equals 9. So I'm going to put a 9 on both sides. So we have done, at this point, steps 1 through 3. Now we're in a situation where we have a perfect square trinomial. What that means is I can rewrite x squared plus 6x plus 9 as the square of a binomial. So I can rewrite this as x. Now in this case, it's going to be, it's whatever it is here. So x plus 3 in parentheses squared is equal to the sum of the 6 plus 9. So plus is equal to a positive 15. And that is step 4. Now step 5 means I'm going to use the square root principle. So I'm going to take the square root of both sides. That's going to give me x plus 3 equals plus or minus the square root of 15. And then I'm going to subtract 3 from both sides so that I can isolate my x. So x equals negative 3 plus or minus the square root of 15. Now be aware that if my math lab is asking you to answer, submit your answers with commas as 2 separate answers, it might not let you put in the plus or minus. So keep in mind that's the same thing as saying negative 3 plus the square root of 15 is an answer, and negative 3 minus the square root of 15 is an answer. If I could simplify this further, I would. But to give an exact answer, that is as far as we can go on that problem. So that is solving by completing the square. You will be required to do that on your test. There will be a specific question in which you're asked to solve by completing the square. There will also be one where you are asked to solve by using the quadratic formula. Now, what is the quadratic formula? So the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. And you can see that is written right here. And it is used to solve equations in the form of ax squared plus bx plus c equals 0, where a is not equal to 0. Very important is that you have that quadratic equation put in standard form to solve this problem. I highly recommend, if you have trouble memorizing this formula, that you associate it with some type of song. There are several songs that people have made, anything from Pop Goes the Weasel to Row, Row, Row Your Boat, saying this equation in those types of beats. Alright, so if I look at this example, I cannot right away say what A, B, and C are. I need to put this equation in standard form. So I need to move that 7 over. So that will be 4x squared minus x plus 7 is equal to 0. At this point, I can say that A is equal to 4, B is equal to negative 1, and C is equal to 7. So when I write this problem and use the quadratic formula, it's x equals negative b, so negative of negative 1 would just be a positive 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, so 4 times 4 times c, which is 7. This is all under my radical. divided by 2 times a, so 2 times 4. Alright, so that means I've got 1 plus or minus the square root of 1 minus 4 times 4 times 7. That should give you 112. All divided by 2 times 4, which is 8. Alright, so this gives me 1 plus or minus the square root of negative 111 divided by 8. Now, we aren't going to leave our answer in that form because right now it has us taking the square root of negative number. So we want to pull that I out. Right? So that would be 1 plus or minus the square root of 111 I over 8. Be very careful. It's very easy in my math lab or using any other computer software to accidentally extend that radical so that it is going over your I. That is a mistake. Be very mindful and careful. You don't want to do all this work and then get marked wrong. Now, if it is asking for your answer in a plus bi form, then you'll further break it down and write it as 1/8 plus the square root of 111 over 8i and 1/8 minus the square root of 111 over 8i. As your solution set. And the last type of problem that we are going to look at for this section is we're going to talk about the discriminant. Now the discriminant is b squared minus 4ac. Now if you recall from the quadratic formula, b squared minus 4ac is your radicand, meaning it's inside of your square root. It's inside of your radical. Now you can use b squared minus 4ac to determine the number of solutions and what type of solutions to expect. So if you just kind of keep in mind the formula, I'm just going to rewrite the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So if you think about it, if b squared minus 4ac is equal to 0, then what are you left with? Then this goes away, that's just 0, and you're just left with negative b over 2a, so one real number solution, right? Now that's a little bit different. So minus 4ac. Now if this value, the discriminant, b squared minus 4ac, is greater than 0, that means you're taking the square root of a real number. And that is why you have two different real number solutions. Now keep in mind the two solutions is coming from the plus or minus, and the fact that they are real is coming because your discriminant is greater than 0. So it's taking the square root of a positive number, and therefore is a real number. Note that if b squared minus 4ac is less than 0, that means that it is in fact negative, so you're taking the square root of a negative number, which is why you have two different imaginary number solutions. So the reason I'm explaining kind of the context of why this is so is so that you don't have a whole bunch of formulas you need to memorize. It should make sense to you. Alright, so we want to use the discriminant to determine the number and nature of the solutions to the equation. Alright, so let's first identify a, b, and c. So a here is equal to 4, b is equal to the square root of 3, and c is equal to 8. So if I look, I've got b squared minus 4ac. B squared would be square root of 3 squared minus 4 times 4 times 8. So this will give me 3 minus 4 times 4 is 16 times 8 gives me 128. So 3 minus 128 gives me negative 125. So negative 125. So if we look at this, our discriminant is less than 0. What this means is I'm going to have two different imaginary number solutions. Now what those solutions are, that's where you would use the quadratic formula, or you could solve by completing the square to find those values. But for the purposes of this question, we just want to know how many solutions to expect and what kind of solutions. The solutions of ax squared plus bx plus c equals 0, where a is not equal to 0, are given by x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, this formula is called the quadratic formula. Very important is that in order to use the quadratic formula, your quadratic equation must be in standard form. So that's the ax squared plus bx plus c equals 0. So if we look at our example, we can see that this is not in standard form. So we need to go ahead and rewrite it in standard form by moving the 7 over to the other side of the equation. When we do that, we get 4x squared minus x plus 7 is equal to 0. At this point, we can determine that a is equal to 4, b is equal to negative 1, and c is equal to 7. And we can plug it in to our quadratic formula. So we have x equals negative b, so negative of negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4ac, so 4 times 4, so that's a, times c, which is 7. That's all under my radical. Divided by 2a, so divided by 2 times 4. This gives me 1 plus or minus the square root of 1, because negative 1 squared would be a positive 1, minus 4 times 4 is 16 times 7 gives me 112. All divided by 2 times 4, which is 8. So I end up with 1 plus or minus the square root of negative 111 over 8. Now I'm going to go ahead and simplify this, so I'm not going to leave it as the square root of negative 111. I'm going to simplify this to x equals 1 plus or minus the square root of 111 I over 8. Now, if you are asked to put it in a plus bi form, then what you would do is you'd say 1/8 plus the square root of 111 over 8i, comma 1/8 minus the square root of 111 over 8i. So just be very careful that you read the instructions carefully so you know the format that it wants the answers in. You don't want to do all of this work to then end up getting the problem wrong and having to do it again simply because you didn't put it in the correct format. Alright, now the next type of problem we're going to look at is we're going to talk about the discriminant. Now the discriminant is b squared minus 4ac. What that is it's your radicand in your quadratic formula. So recall that the quadratic formula is x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Now what the discriminant can tell us is it can tell us about our solutions. It can tell us if we have one real number solution or if we have two different real or two different imaginary number solutions. And that's all based on what your discriminant is in relation to 0. Is it equal to 0? Is it greater than 0? Is it less than 0? Now, I'm going to explain a little bit about the reasoning why, just to kind of give you some relief as far as memorizing formulas. That if you understand why, it's not so much of memorizing the formula. Alright, so if b squared minus 4ac is equal to 0, then you have one real number solution. Well, let's look at why. So if b squared minus 4ac is equal to 0, then this is 0. This is all gone. So you're just left with negative b over 2a, therefore one real number solution. However, if b squared minus 4ac is greater than 0, then what you're doing is you're taking the square root of a positive number. So it'll give you a real number solution. The reason why there are two is because of the plus or minus. Similarly, if you've got b squared minus 4ac and it's less than 0, you would have two imaginary number solutions. Keep in mind that they'd be imaginary because you'd be taking the square root of a negative number. So let's look at our example here. It's already in standard form. So we have a is equal to 4, we have b is equal to the square root of 3, and c is equal to 8. So if I take b squared, that's the square root of 3 squared minus 4ac, so 4 times 4 times 8. So this gives me the square root of 3 squared, just gives me 3. Minus 4 times 4 is 16 times 8 gives me 128. So I end up with an answer of negative 125. So in this case, b squared minus 4ac is clearly less than 0. Well, when it is less than 0, I end up with two different imaginary number solutions. And that's all we can tell as far as the discriminant. All it is going to let us know is the number of solutions and a characteristic about them as far as if they are real or imaginary.